Welcome back to the Diamondback CSST training. Section 3, System Configuration and Sizing. In this section, we will help you understand how to size and configure your installation of Diamondback CSST. As this training is only for those already certified as gas fitters, we do expect you will have the knowledge and training for gas pipe installation. This training is to help you understand the specifics of Diamondback. When planning your installation of Diamondback CSST, 4 pieces of information are required to correctly size any fuel gas piping system. First, the gas supply pressure and allowable pressure drop. Second, the length of each line in the fuel gas piping system. Third, the BTU per hour input rating of each appliance in the system. And fourth, the sizing table that matches the gas supply pressure and allowable pressure drop. The Diamondback sizing tables start on page 44. Here is Table N1. The key to selecting the right table relates to the supply pressure and the allowable pressure drop. In this example, the supply pressure is 7 inches water column and the allowable drop is 0.5 inches water column. Along the left column are the different diameters of Diamondback pipe. Across the top are the different lengths, and the numbers in white correspond to the load. In the sizing tables, CFH is equal to approximately 1,000 BTUs. The EHD column has numbers that increase as you go to bigger pipe. This is a relative measure of flow capacity. Please note that the numbers are based on 0.60 specific gravity gas. The table includes losses for 4 90-degree bends and 2 end fittings. To compute flow capacity for tubing runs with a larger number of bends and/or fittings, add the appropriate number in feet to the actual run length using the following. Multiply the additional number of bends or fittings over 6 by 1.3. Then add that resultant number to the total number of feet. So if you had 5 additional bends, that would be 5 times 1.3, which equals 6.5. So if the total of the line was previously 35 feet, you would add the 6.5 feet to that, so it would equal 41.5 feet. There are additional tables in Chapter 7 of the manual which relate to different supply pressure and drop situations. Also, there is a chart for black iron pipe, although that one indicates measurements in straight BTUs, not CFH. Okay, now back to an actual sizing example. The low-pressure series system, conventional arrangement, is sized in the same way as a conventional low-pressure black iron pipe system using the sizing tables. This method is known as the longest run method. The pressure drop in a low-pressure system is usually limited to 0.5 inches water column over the system. Medium pressure systems can have pressure drops of up to 6 inches water column. So, to help explain, let's use the longest run method and work out the sizing in this low pressure example. Here's a layout of a home installation. In it, you will see the outside gas meter, the furnace, and the water heater. In between, of course, is the Diamondback CSST pipe, a T, and the line shutoff valves. Note that the supply pressure here is 7 inches water column with an allowable drop of 0.5 inches water column. To size Section A, determine the longest run. The longest run is the length from the meter to the furthest appliance, and total gas load for each appliance in cubic feet per hour. 1 cubic foot per hour equals 1,000 BTUs. The meter to the furnace is A plus B, which is 10 plus 10 equaling 20 feet. The meter to the water heater is A plus C, or 10 plus 15 equaling 25 feet. This is the longest run. The total load includes the furnace plus the water heater, equaling 65 plus 35, which totals 100 CFH, or 100,000 BTUs. So now you need to select the correct table in the design manual. In this case, it is table N1, page 44. That table is 7 inches water column with 0.5 inches water column drop. Using the longest run method, select the column showing the measured length, or the next longest length if the table does not give the exact length. Referring to table N1, the column for 25 feet of piping shows that sizes 3/8 inch and 1/2 inch are too small, and the next available size is 3/4 inch, with a maximum capacity of 158 CFH. The correct size, then, is 3/4 inch. Determine the length of run from the meter to the furnace and the load delivered. The length of that run is A plus B, or 10 plus 10, equaling 20 feet, with a load of 65 CFH, or 65,000 BTUs. Table N1 shows that size 1/2 inch supplies 77 CFH, so the correct size is 1/2 inch. To size section C, determine the length of run from the meter to the water heater and the load delivered. A plus C, or 10 plus 15, equaling 25 feet. The load on that run is 35 CFH, or 35,000 BTUs. Table N1 shows that the 3/8 inch tubing has a maximum capacity of 33 CFH, so that is too small. The correct size, then, for that run is 1/2 inch.